When a granular mixture of different sized materials is shaken or vibrated, the larger particles rise to the top. This phenomenon is called a granular segregation, or more popularly as the Brazil nut effect. It's a common everyday experience to open a box of muesli to see that the large sized nuts are at the top of the box. Let us demonstrate the Brazil nut effect with two different experiments. First, I take a bunch of nuts. Here we see a large walnut, we see pistachios, we see peanuts, we also see a Brazil nut. And I'm going to vibrate this column filled with nuts. Watch the large walnut find its way to the top. I do another experiment in which I take a glass column and fill it with two types of materials: silica particles of 2.8 millimeters with a density of 700 kilograms per cubic meter, colored blue at the bottom, and smaller polystyrene particles with a lower density of 200 kilograms per cubic meter, colored yellow, you might say, at the top. Let's vibrate this column as well. The larger, heavier silica particles, colored blue, have risen to the top. For an explanation of the science behind the Brazil nut effect, visit this YouTube channel. Also, read the paper I co-authored with Ellenberger and Vandu on the conditions required to realize the Brazil nut effect. Both the vibration frequency and amplitude need to be large enough to realize the Brazil nut effect. Lower frequencies and lower amplitudes result in the reverse Brazil nut effect. Let's demonstrate that with two different experiments. On the left-hand side, we take a column filled with polystyrene particles colored white, and we have a large brass intruder that is heavy and has a density of 5,300 kilograms per cubic meter. The polystyrene particles are 1,080 kilograms per cubic meter. And I'm going to vibrate this column at a high frequency. You see the intruder has risen to the top. On the other hand, if I vibrate the same column at a lower frequency and lower amplitude, let's see what happens. The brass intruder sinks to the bottom. In order to understand the differences in the two different experiments where we have realized the Brezhnev effect and the reverse Brezhnev effect, let's focus on the brass intruder and see what happens in these two cases. Let's start with vibration at a high frequency. We see as the particles are vibrated, we create a void space below the intruder, and as the intruder rises, the void space gets filled up with the lighter polystyrene particles. So the void filling mechanism is the reason behind the rise of the larger, heavier brass intruder. On the other hand, if the vibration occurs at a lower frequency, then the phenomenon of void filling cannot occur, and the large heavy particle sinks, and we have the phenomena of digging, or the reverse Brezhnev effect. Let's have a look. In order to understand the sinking, we have here a marker, and we see relative to the marker, the large brass intruder is progressively sinking or digging. Higher frequencies, larger amplitudes result in the Brezhnev effect. Lower frequencies, lower amplitudes result in the digging phenomena. These are explained in this publication, Powder Technology 2006.